All right. So today we're going to do chapter 2. This is going to be Google Cloud Security Concepts. So welcome back. This chapter, we're going to explore the fundamental security concepts that form the foundation of Google Cloud Platform. We'll examine infrastructure security, compliance frameworks, the shared responsibility model, and how Google implements multi-tenant security at scale. So here's a general overview. Google Cloud infrastructure is built from the ground up with security in mind. Every component is designed to support multi-tenancy, where multiple customers securely share the same physical infrastructure. This begins with a critical principle. Only cryptographically and authenticated and authorized application binaries are permitted to run within Google's environment. Google applies zero trust principles throughout its architecture, meaning multiple security mechanisms work in concert to establish and verify trust. For every API call traversing Google's network, TLS encryption is strictly enforced, ensuring data confidentiality and integrity. One of the advantages of Google's massive network footprint is its inherent ability to absorb and mitigate distributed denial of service DDoS attacks. The platform automatically provides protection against volumetric attacks targeting network layers 3 and 4, backed by a 24/7 incident response team monitoring for emerging threats. So hardware security, the Titan chip. Let's go to this. You'll see this here, and I'll drop this in the chat. Anyone looking at this should be able to get to the original. At the hardware level, Google employs a custom security chip called Titan. This specialized hardware establishes a hardware root of trust, verifying system integrity at the nanosecond level during the boot process for servers and peripheral devices. The Titan chip validates cryptographic signatures for all low-level components, including BIOS, bootloader, kernel, and base operating system images. This verification happens both during the initial boot sequences and subsequent update cycles, ensuring the integrity of the entire technology stack. So you can see a little image here. This will be a Titan security key. It's phishing resistant, second factor of authentication, good for users like cloud admins, and built with an element that includes the firmware. Basically, when you have this key in your hard drive, or excuse me, in your computer, this allows verification to your environment. Without this key plugged in, you cannot get into the environment. So understanding this, the purpose of enhanced hardware security through a hardware root of trust can be seen as the Titan chip is a custom security chip developed by Google. It ensures system integrity by verifying the boot process and firmware, and Titan provides secure key storage and cryptographic operations. You can find these articles on wired.com. Let me see if I can ping one here, and then add this to the chat as well. See if I can get another one here. All right. I think these are actually the same. No, this is another. This is a later one. Okay. All right. I'll put that one here as well. All right. And you can look at this for a little bit more expansion. So Titan is integrated into Google's infrastructure and devices, and users don't need to configure it manually. All right. And I did show you the original page where you can find this information here. So we'll go into data privacy controls. Google has implemented robust privacy controls to earn and maintain customer trust. A notable example is access transparency. Okay, let's get over here. All right, this provides customers the visibility when Google engineers access their environment. When access does occur, Google provides detailed logs and contracts with third-party assessments and are prioritized to ensure compliance. It's important to understand that as a customer, you maintain control over your data. Google doesn't access or move it without permission, doesn't sell your data, and doesn't maintain backdoor access. All communications crossing physical boundaries are encrypted, as is data at rest, creating multiple layers of protection for sensitive information. So how do you enable this, right? Purpose is, let's see, you want to maintain, monitor, and log actions taken by Google personnel when accessing your data. Let's go here. Here's an overview of access transparency. I'll add this in to the chat. Anyone who's reviewing this can access this chat and see the URLs and go into this in specifics, right? So you go into when to use this. You'd be verifying that Google personnel are accessing your content only for valid business reasons, such as fixing an outage or attending to your support requests, verifying Google personnel Access aligns to the products and services you're seeking assistance with, verifying and tracking compliance with legal or regulatory obligations, and collecting and analyzing tracked access events through an automated security and information and event management, such as a SIM tool like Google Security Operations. All right, and this all goes down into this. So, how do you go here? Let's go to the Access Transparency page. Oh, let's see. Access Transparency. Enable. There we go. Go to identity. So, how would you do this? Go to your organizational level in the IAM page, and then, if prompted, select Google Cloud Organization. Verify you have the IAM role, Access Transparency Admin. Let's see, since this is org level, we'll try and enable it with this button. Huh, might not be able to be done. Let's see. Access. Nope, it's not available here. That's okay. So it's available for specific services and may require enrollment. So this looks like an organizational level piece. That's okay. Now that you know it's at the organizational level, then you know where to enable it. And I'll add that in the chat. All right. So the shared security responsibility. Google Cloud offers various service models, including infrastructure as a service, platform as a service, and software as a service. With each model comes a different division of security responsibilities between Google and the customer. Rather than a simple shared responsibility model, Google approaches this as a shared fate mindset for comprehensive risk management. This means Google actively partners with customers to implement security best practices during both cloud migration and ongoing operations. So, how do you address compliance on Google Cloud? For organizations concerned with regulatory compliance, Google Cloud maintains an extensive list of compliance certifications and badges. All Google Cloud products undergo rigorous third-party assessments with compliance controls to achieve certifications for standards like PCI DSS, ISO, SOC 2, and others. As a customer, you inherit these security protocols, significantly improving your security posture without having to implement every control yourself. Google complies with international standards such as the Personal Data Protection Act, PDPA, and maintains regularly updated lists of compliant services on its website. So, while Google provides the compliant foundation, you must ensure your specific system design maintains compliance requirements. Google's approach to security involves multiple technology stacks deployed in layers to secure infrastructure, identity, and user. Let's explore how this works across different security domains. This will be security by design. So let's start with operational security. Operational security encompasses how software services, devices, credentials, insider threats, and intrusion detection are deployed and managed. Google maintains secure central control with two-way code reviews as a standard practice. The company employs specialized libraries to prevent common vulnerabilities like cross-site scripting, that's XSS attacks, and the development process includes automated tools for static code analysis, vulnerability identification, and security testing across web security, cryptography, and operating systems layers. To further strengthen its security posture, Google runs vulnerability reward programs incentivizing security researchers who discover bugs in its infrastructure or services. Through its Beyond Corp enterprise security model, Google ensures users have timely access to designated applications while continuously monitoring devices and user behavior. This includes regular patching and updates, robust authentication measures, two-factor authorization based on geolocation, and network address restrictions for authorized users. All activities by users with access to end user data are comprehensively logged and monitored for unusual access patterns, allowing for rapid investigation of anomalies. Intrusion detection at Google uses sophisticated techniques of processing pipelines to analyze host and network level signals. These systems combine rule-based detection with machine learning to identify potential security issues around the clock. Next would be network security. A key advantage of Google's network architecture is that traffic generally doesn't transit the public internet, making it substantially less vulnerable to attack, interception, or manipulation. Google secures its Google front ends, GFEs, that interface with services, ensuring correct certificate usage for TLS termination, implementing perfect forward secrecy, and providing multi-tier, multi-layer protection against DDoS and volumetric attacks. The platform employs layers of hardware and software-based load balancers with both network and application awareness. These controls, combined with Google's global infrastructure, ensure that attacks are effectively absorbed and mitigated. Before allowing access to its network, Google enforces strong authentication that goes beyond traditional username password approaches. This challenges users for additional information based on risk factors like location, IP address, and device type. So let's go into data security a bit. Google Cloud protects data both in transit and at rest using various encryption types. These can include, for customers, to have full control over the cloud key management system. Okay. Okay. Let's go in here. All right. This includes key lifecycle management defaults, and for organizations with specific compliance requirements, Google offers several advanced options. BYOK, so bring your own key capabilities, multi-tenant cloud hardware security module, that's the HSM, with FIPS 142, level 3 protection, and support for external HSMs through third-party services. Data must be secured throughout its lifecycle, whether being created, shared, stored, analyzed, archived, or deleted. When using any service, customers must maintain compliance with service-specific policies to ensure continuous protection. Let me go back and make sure I got this correctly. Da, 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 da. Okay, so this is the cloud key management. Let's go into this. So key management rings. This is the cloud key management service. This is the key ring. This is how these are set up. Okay, so we're at the cloud key service management page, right? Within this, we have enabled APIs. Oh, it went to the API. Excuse me. All right, so let's create a key ring, right? We can provide a general name, just Jules key ring, have it multi-region for higher availability. All right, we could choose global and oh, I already have this. One. All right. And now let's go with this. And we can create a key name. Just equals key 02 2025. All right. We'll have it as software level, HSM, put it software level. Continue, generate the key. Let's choose some metric. Rotation period, 90 days. And that's just additional scheduling for destruction. So we'll create key, be okay. All right. And now let's create storage. All right. So we'll create a bucket example. Tools, bucket, or key ring. We could add, just so you know, you can add labels. We're going to make this multi-regional as well. Continue. We'll set a default class for standard. We're not going to have anything in here. All right. And then store your data. Let's see. Uniform access control. Okay. Soft delete policy. Use delete. And then data encryption. This is where we're going to be. We're going to use a cloud KMS key. And then it should be here. This tools. Why isn't this here? It should be here. Key ring. cloud key. Let's try it and go back to this. Oh my lordy. Let's try this. Oh my goodness. Security keys. Key management. There we are. Yeah, it should be this key. Google managed. Maybe it's Google managed. No, it's not. Um, object versioning, so this can be enabled in multiple regions. Retention, that's so you can set up so that you don't delete this on accident. Why am I not getting this? Huh. This is Google managed. Let's cancel this. Let's see if I can add this key to this. So protection. Permissions. No. Well, looks like I'm not doing this correctly. Oh, wow. Storage insights. Let's go to storage. All right. Okay. Well, this can also be done with the CLI. All right. So one way you could do this is create the key, authorize that. All right. So one way you could do this, gcloud KMS key rings, create my key ring, where in location US Central 1, right? That's how you would create a key ring called my-key-ring, right? And then you could create a key. I'm just going to copy and paste this from a little experimental document. gcloud KMS keys create my-key in US location US Central 1 for the key ring my-key-key ring. Purpose encryption, right? That's what you created. And then you could create the bucket with the gsutil commands, right? gsutil mb make bucket p for the project ID. So it'd be this project ID right here. And then you would have the location US Central 1 B on GS my secure bucket, right? And then you could set the customer managed encryption key on the bucket with the following command: gsutil kms encryption -k projects on your project ID right here, right? Locations US Central 1 key rings my /1 /key rings my-key-ring /crypto keys /my key on the name of the bucket. All right. Now that's how you would actually create the key ring, create the key, create the bucket, and then set the key on the bucket. So it might be a little bit easier to do it from the command line. And this will give you how to correctly do this. Okay. So let's close some of these tabs. Getting a little bit overloaded here. All right. All right. Now here's actually a good image. You can use this as well for the keys. This gives you a setup for how it runs. The user, whether they're running something like BigQuery or Compute Engine, uses the key management service, an external key manager. Customer keys are important for the encryption. That is key for that bucket, or if you want to have something that actually handles workload, like EKS, or I'm sorry, like like Compute Engine, like BigQuery, and you can see how this would run. Cloud storage, confidential VM, external key manager, on-premises compute. Okay, and then you see how there's different types of encryption that go along with this. Different features like Cloud KMS lets you create, use, and rotate automatically with AES 256 symmetric or RSA 2048. These are basically different encryption standards, right? For symmetric or asymmetric keys. Then you can also create external keys with ECAM. So you can see these external keys through the following external key managers: Equinix, Fortanix, Ionic, Thales, or Unbound, right? Once you link your external key with Cloud KMS, you can use it to protect data in BigQuery or in Compute Engine. You can delay the key for destruction. You can go for using this for encrypting and decrypting right here. Then you can make it globally available, which I showed you from single region or multi-region. That's the availability of that key. And there's a bunch of different standards. Automated and at-will key rotation. So if that key gets somehow made available to someone who shouldn't have it, you can actually delete the key and then rotate out that old key, destroy it, and then create a new key, right? And then you have a statement attestation with HSM. This verifies that the key was created with the hardware. So this attestation works with tokens generated for key creation operations. It also integrates with Kubernetes at the application layer, which helps with your Cloud KMS, and you can also store APIs. This is going a little bit more in security key management, which is closely related to what we're going to do next, which is good. All right. Well, maybe not next, but it's going to be coming up. Okay. Next up, we're going to go into secure services and identity. Let's see if I can go back here. And this might not be the right one. For human system interactions or system to system calls, Google applies cryptographic authentication and authorization at the application layer. While network, perimeter, and segmentation firewall rules play a role, they're just one part of the comprehensive security strategy. Each service operates with its own service account using cryptographic credentials to authenticate and authorize remote provider calls. Okay? Services are protected through isolation and sandboxing mechanisms, with security implemented at the language, kernel, hardware, and operating system levels. Google's infrastructure provides strong privacy and integrity as data traverses its networks. HTTP, for example, is encapsulated within remote call infrastructure. For enhanced control, service owners can configure crypto-based protection, integrity level protection for data, and automatic data encryption between the wide area network and data centers without additional configuration requirements. So physical and hardware security. Okay. Google's data centers are designed and built with physical security as a priority, incorporating security by design principles and redundant security layers for physical access control. Access to data centers is strictly limited to required personnel and protected by comprehensive security measures, including closed circuit television surveillance, vehicle barricades, biometric identity verification systems, access controls for authorized staff, background checks, intrusion detecting and monitoring systems. So while some facilities are managed by third parties with additional control measures to ensure consistency and compliance across all locations, Google has started from the security based at physical level first. Google meticulously vets component vendors and audits the security of hardware components. Specialized trips like Titan enhance hardware security and authenticate devices throughout the infrastructure. Secure boot capabilities are becoming increasingly common, with customers expecting this level of protection. This technology ensures secure, and correct software operation through cryptographic signatures and hardware-based root of trust, guaranteeing that the entire stack, from data center to API, services, and software, runs on validated and secured infrastructure. So threat and security management. Let's examine the components of crucial. Let's examine the components crucial for cloud security adoption. This includes vulnerability management, malware protection, incident response, and security monitoring. Keeping infrastructure secure from cyber threats requires multiple technical controls and techniques addressing various attack vectors. Google employs both manual and automated penetration testing, comprehensive security assurance programs, and mature software systems with automated secure code scanning and manual reviews. This approach ensures vulnerabilities are identified, managed, contained, and controlled based on severity within the team's established frameworks. As malware attacks continue to grow in both variety and volume, organizations must build strong controls and processes. Google Safe Browsing scans billions of URLs daily to identify unsafe sites. The company also operates VirusTotal, a service that analyzes suspicious files for Trojans, backdoors, worms, and other malicious software. Additionally, Google Drive and Gmail incorporate malware identification capabilities to enrich, manage, and contain potential threats. Google's security teams monitor and flag suspicious behaviors and traffic patterns that might indicate botnet connections. The company's threat analysis group and Project Zero combine proprietary and open source technology to identify threats and scale multiple public data repositories, both manually and automatically. For incident response, Google aligns with NIST SP 861 standards. This ensures rigorous compliance to contain and resolve security incidents while applying organizational learning from each event. The comprehensive approach enables 24/7 incident response capabilities. This supports customers and documents workflow for recommendations. So how do we incorporate this and how do we implement it? Let's explore some practical examples of how to implement security in Google Cloud environments. 1. Network security implementation. When configuring a compute engine instance that should have no internet access or access to Google APIs, you must ensure two critical settings remain disabled. Let's get a compute engine up here. Okay. So when configuring a compute engine, you look at the public IP address. This must not be assigned to the instance. Let's go in here. And private Google access must be disabled on the subnet. So this limits your outbound connections and denies your inbound connections. Okay? So Google VPC networks have two implied firewall rules by default. A rule allowing all outbound connections and a rule denying all inbound connections. For scenarios requiring secure storage of secrets rather than storing them as plain text in source code, we have management systems that have best practices to encrypt these secrets with customer managed encryption keys and store them in cloud storage, which we just walked you through earlier. So let's go over a little bit of the firewall rules. Okay. Firewall rules will be here under network security, but you can also find them under the VPC network with firewall. Okay. So you have your firewall policies. All right. And then this starts from the VPC network, which is the backbone. It's a software level programming for all of your inbound, outbound, and intra communications within your Google Cloud environment. All right. So we're at the VPC network on firewall. We can create a firewall rule right here. Let's see. So you can create this with the name, description. You can turn on logs, or should turn on logs. So it can increase costs, but it is good to have your logs to make sure you have a secure environment. Set to your network. It's set to the default because that's the only VPC we have. And to set the direction of traffic, we have this set to ingress. And the action on match, we'll set to allow, right? So what is this? When traffic matches your parameters, you can allow or deny that traffic, right? Then your targets, you can choose all instances on the network, or we can specify target tags, service account, whatever is managed, right? And then under your CIDRs, set the IPv4, or you can do tags or account. Then you set this according to RFC 1918. So that'll be 000 is all, which you really don't want. You can do 10 dot, you can do 172 dot, or you can do 192 dot, or I believe it's 178 dot. And you can set a secondary source, but that would require another filter, but we haven't set the primary one. Then you can set your ports and protocols for TCP, UDP, STP, or another one, maybe SMTP, maybe FTP. There's all sorts of protocols you can do. Telnet, something along those. And at the bottom, you click create. You can also do it in the CLI. I'll type this one. Reconnect. Okay. All right, so this is G Cloud Compute Firewall Rules, create allow SSH from office. Next line, direction would be ingress, priority would be 1,000. If the closer that is to 0, the higher the priority. The closer is to 65,535, the lower the priority is. Okay, so 1,000 is a pretty high priority. Set the network for the default. That's the default VPC. Action allow, like we spoke about. Rules for TCP port 22, and then the source ranges shows the IP is at 203.0.113.0/24. And then target tags would be SSH-access. All right, that gives you a good idea of what you can do by implementing this. All right, but we're gonna delete that and we're gonna go into something a little fun. Well, it's all been fun so far. I am. All right, we'll do IAM access. Okay, so when centralizing GCP IAM permissions based on Active Directory group permissions, use Cloud Directory Sync to synchronize groups and assign IAM permissions accordingly. Let's move this over a little bit. Yeah, we're going to do this with Google Directory Sync. Okay, so this is for building secure container images. To do that, you follow these two key principles, right? One, package a single application per container to minimize the attack surface. Two, remove unnecessary tools to reduce potential vulnerabilities. When restricting access to internal web applications by CIDR blocks while leveraging Google Cloud's native SYN flood protection, VPC firewall rules are the appropriate solution. For connecting on-prem workloads to Google Cloud from internal networks, you have two primary options: Cloud VPN for encrypted connectivity and Cloud Interconnect for dedicated connectivity. In the next portion, we'll delve a little bit deeper into identity and access management on Google Cloud, exploring best practices for securing your cloud resources through proper identity controls and permission management. So this is going to be done at the organizational level. So the next thing is integrating Active Directory with Google Cloud. All right, this will be a good example of how to use Google Cloud Directory Sync. Google Cloud Directory Sync enables administrators to synchronize users, groups, and other data from an Active Directory / LDAP service to the Google Cloud domain directory. All right, so the first thing you do would be to download and install this. All right, once you have it, we'll just download it just to show you. I don't have the use for it, so I'm going to delete it. The next thing you'll do, you open up the setup document, configure it with your LDAP configuration. So you enter your Active Directory details. Then you go through a Google domain configuration where you enter your Google Workspace or cloud identity details. Then you define your synchronization rules for users and groups. And then you can sync this. You can run a simulated sync to verify settings, and then schedule regular synchronizations to complete this. All right, but I'm going to add this. So you have this. That's the main page. All right. All right. So one, you want to ensure network connectivity between GCDS and both Active Directory and Google Cloud. All right. So that is the end of chapter 2. Chapter 3 will be on trust and compliance. Thank you. Have a good day.